and a particularly warm welcome to this latest in the webinar series at the NIHR-supported Incubator for AI and Digital Healthcare. I'm Jeff Hogg, a clinician scientist based between one of the larger universities and NHS trusts in Birmingham. For those of you that are joining us for the first time, the NHR-supported Incubator is a cross-sector community aiming to collectively advance regulatory science and innovation in AI and digital healthcare. And this demand-led webinar series is the vehicle for us to be able to explore some different ideas. So we get the chance to invite experts on to share their work and insights in key areas and give us an opportunity to dig into the topics and bounce questions and discussion around. So the format of these sessions very much hold that in mind. So soon I'll be quiet and we'll be able to enjoy a presentation from our speaker today. And we'll all be in listening mode for that part, but you'll notice a Q&A button down at the bottom. So if you have ideas or thoughts, questions pop to mind, then please do feel free to type away as they occur to you. But we'll dig into them at the end in a Q&A session. We should have ample space for that. And I'll try to unmute you on Zoom so you can speak to the questions yourself, but if that doesn't work, I'll be able to read them out. Don't worry if we don't manage to get to everybody's questions. It's really valuable for us to get a sense of what kind of topics or thoughts we can dig into more in later installments in the series. The last thing to mention is it will be recording today's session and it'll be hosted on the website, so you can rewatch that at a later date or recommend it to a colleague or a contact who might want to catch up too. So, in these webinars, we've heard about quite a few different specific use cases for AI in healthcare, but just like the products that are on market, these use cases are often focused at individual level care. Data from discrete patient cases are processed to advise clinicians whether that individual is likely to be admitted to hospital soon, to have an abnormal chest X-ray, or perhaps have suspicion of skin cancer. But today's discussion will highlight some of the challenges these types of individual-focused use cases have, and look at the potential of AI technologies with a wider scope of impact as public health tools. To take us on that journey, it's a great pleasure to welcome Dr. Jessica Morley to the incubator, whose research focuses on how to ensure the use of AI in healthcare is not only technically feasible, but socially acceptable, ethically justifiable, and legally compliant. Jess is an associate research scientist at the Yale Digital Ethics Center. She's an associate editor of BMJ Digital Health and AI, and previously was policy lead for the Bennett Institute for Applied Data Science at the University of Oxford. So thanks so much for joining us today, Jess. I'll hand over to you to share screen and take us away, if that sounds okay. That's coming up really nicely. Thank you.
All right, let's crack on. Okay, so first of all, thank you so much, everyone, for having me. I know it's extremely hot back at home, so hopefully I will try and keep the energy up and give you some things that are interesting to think about and help distract from the sort of afternoon siesta slump of the heat. You can see from the title, my pitch is sort of AI for health equity and why we should be coding for we and not for me. But let's just do a little bit of a map of where we're going so that you understand what I'm going to talk about. So first of all, I'm going to talk about what is AI. Don't worry, I'm not about to give you a sort of mansplaining explanation of what I think AI is. This is just a way of reframing how I think about AI. It will help make sense of what else I'm going to say in the rest of the presentation. I'm going to talk a little bit about why I think this idea that the way in which we can get the best use out of AI, as Jeff said, is this sort of predictive optimization of individuals, and why I think that's a little bit flawed, and why I think that might be giving the system some false hope. And essentially, I will then explain why this is a bit of a problem. And this goes throwback to some old epidemiology theory from the 1980s. And then we'll talk about a theory-led alternative and what I think we should be doing instead. So basically, a big picture, depress you, and then hopefully lift you back up out of the depression. So to start with, just this question of what is AI? So everybody here, I'm very certain, is familiar with this sort of technical definition that it's data and algorithm plus model, which allow us to do things that would require intelligence if it was done by a human. And you get these variety of different types of technologies that we're talking about when we're talking about the use of AI in the healthcare system. So sort of from computer vision, which is one of the most common uses of AI in health. It's also one of the most quote unquote solved uses of AI in health, in that we know when it works and what it's doing. We might use natural language processing or LLMs increasingly, so parsing and producing text. That's anything from, can we use AI, as I'm sure everyone is, now familiar with, like using an ambient scribe or generating free text, but also things like, if you've ever come across stuff like Cogstack, which is basically making the text that sits inside electronic health records searchable and more usable. You have reinforcement learning, which is learning policies from feedback. So in an individual space, that would be things like, for example, personalized insulin dosing and learning in real time what that patient is most likely to respond to. But it can also be things like where you're doing dynamic understanding of things like clinical trials and adapting the trial in real time, or it might be adapting things like the care pathway in real time. And then more broadly, you have generative AI, which is not just the production of text, it's also the production of anything new. And so we might have things like, we had AlphaFold learning the protein structure, but you might also have things like synthetic data for rare diseases where we don't have enough raw data. Can we generate the fake data or the synthetic data that enables us to try and understand patterns with regards to diseases? It's also extremely common now to use these types of AI for things like drug discovery. But I tend to try and think about AI in a little bit different way, not just this very mechanistic understanding of it being data plus algorithm plus model, and think of AI as being this new form of agency that separates the ability to problem solve from the need to be intelligent, and that operates at the systems level. So instead of it just being, can you do task A and can I sort of automate task A and then it produce the outcome that I was expecting, it's really about thinking about, okay, so I now no longer need human intelligence in order to solve this specific problem. That actually gives me an enormous amount of power and opportunity to play, because I don't need to organize the healthcare system in the way that has traditionally been organized, which has been sort of organized around this idea that human is the person who needs to solve the problem, whether that problem be diagnosis or whether it be things like optimization of flow through a hospital, and that things need to be co-located. When I can separate those things apart, I get an enormous amount of power and opportunity, which is what I mean by here. So if we think about what this sort of new opportunity gives us, this ability, this new agency to separate problems from the need to be intelligent in order to solve them, it allows us to separate things out and rethink them through. So we can separate things like symptoms from diagnosis, where we have traditionally thought that the symptoms A, B, and C equals diagnosis D. This might not actually be the case. Maybe some of those symptoms are not necessarily associated with this disease, or maybe there are new symptoms that are associated with that diagnosis from a different representation of the population. So whether that be from minority groups who were traditionally not included in the sort of database, or elsewhere. And it also separates knowledge about the body from the body. So what do I mean by that is that we're really, when we're talking in an AI space, talking about treating the individual person and their individual body. We are actually treating the knowledge that we have about that body in a sort of structured form. And that might be knowledge that comes from like a wearable or an app, or it might be knowledge that comes from an electronic health record, or it might be somebody's Google searches or what they post on Twitter or X, or it might be increasingly it might be what they are interacting with something like ChatGPT. None of that is actually physically involved in that person's body. And that starts to raise very interesting questions about what does it mean, for example, if a patient says, I don't feel very well, all of their data says that they are fine. Who do you believe, the patient or the data? Do you even speak to the patient? And then the more obvious ones, like, for example, separating clinical knowledge from the clinic or from the clinician. So we no longer need to have things co-located. At the same time, agency allows us to rejoin things together that were potentially separated. So this is about joining together the patient and their data. So as I was saying, if you separate knowledge about the body from the body, what you do actually do is you join together the patient and their data so they become one and the same, because you are no longer treating the patient, you are treating their data profile or their data shadow. And so anything that the data is representing becomes true of the patient, and equally anything that is not in that record is no longer seen and is no longer visible. It also joins together research and practice. So I'm sure everybody in this on this call is known that in medical research for a very long time, for very good reasons, because of historical atrocities that happened, we have separated medical research from medical practice in a very severe way. Turns out that when you're doing AI, those barriers start to break down. If we are using, for example, an algorithm that's learning in real time, like I was talking about that reinforcement learning, when it's doing things, for example, like learning the insulin of that particular patient, say that's then happening across multiple different patients, and that information is also being passed back up the system to change things like NICE guidelines for dosing of insulin for diabetic patients. That is a research project that's happening in real time, as well as it being something that's happening in medical practice. And how we govern that is quite complicated, because essentially we just don't really know how all of the mechanisms that we have developed over a long period of time to both govern research and then to govern practice are sort of designed as if those two things are separate. And when they become joined together, it starts to get a little bit more complicated. And then also, as will become a bit important in my next few slides, we're also joining together big tech and healthcare. The vast majority of AI for healthcare products are not being developed in-house by clinicians. They're not coming from the NHS itself, for example. They are coming from third-party private providers. That's not inherently a problem, but it is something that we have to think about, especially when it comes to things like power dynamics and where that data is flowing. So essentially, once we start thinking about AI, it's not just being this one particular model or this one particular product, and it's not just this idea that what I'm doing is taking what was an analog process and I'm making it an automated process, and it's instead this new form of agency that allows us to play with the system. We can redesign everything. We can redesign everything from the cancer pathway to what counts as evidence of illness to the role of the clinic. It's all reconfigurable, and that's incredibly powerful. It's incredibly exciting. It's also incredibly dangerous. So now I've explained why we have all of this sort of power and opportunity. And now I want to focus a little bit on where we are pitching all of that power and opportunity when we are thinking about it as a systems level technology, and now that's what policy is trying to achieve at a systems level with the use of AI. So I'm pretty certain everybody here is mostly clinical. We have a lot of the practitioners will know that healthcare in the UK is suffering quite substantially. We've never spent more in real terms on the NHS, and our outcomes have never been worse. We have now the lowest level of healthy life expectancy that we've ever had on record. We also have one of the lowest levels of healthy life expectancy in the whole of Europe. That is declining, and most importantly, going given sort of my focus and interest, and also because the NHS is based on this principle of solidarity, those healthcare inequalities are widening. So now if you take healthy life expectancy, it now varies by more than 15 years across different localities. So in one area, the lowest level of healthy life expectancy is now 55, and the sort of highest level is 70. And this turns out quite a big, that's something we should really care about when we have a system that's built on solidarity and from health equity. So we have just really got this big problem. The government's mission, as I'm sure anybody who's read the Fit for the Future plan, is that they will solve this problem by shifting the system from sickness to prevention. And we will therefore solve all of the problems because people will not become sick. And if we focus on prevention, that's where we're going to get improvements in equitable population health. The issue with that is that the prevention has traditionally been a public health endeavor. It's something that belongs to the public health system rather than it belonging to the clinical system. And public health spending has actually declined by 26% in real terms in the last decade. So we've essentially created this scenario where spending on clinical care has increased, spending on public health has massively decreased, outcomes are worsening, and inequalities are widening. So this is the problem that that the government thinks AI can solve. It thinks that what we can do is enable this transition from sickness to prevention through AI-enabled P4 medicine, so predictive, preventative, participatory, and personalized medicine. And this basically shifting the responsibility for prevention from the state and the system onto the individual. So we're essentially shifting from primary prevention to secondary prevention through this idea that I can predict when you're going to become unwell. I can then tell you what to do in order to prevent you from becoming unwell, and then you will do it, and then we will intervene. And so you get this logic. It comes through incredibly strongly in Fit for the Future. It talks about making the NHS the most AI-enabled healthcare system in the world in a sentence that is free-forwarded with the listing of genetics, wearables, data, and predictive personalized intervention. The expected result of this, and when we start seeing it at a policy level, is that this is going to produce better outcomes for all, and it's going to lower the cost. So essentially, we're going to shift the responsibility for prevention from the state to the individual, and this is going to simultaneously help us achieve the shift from sickness to prevention, and that is going to make everybody both healthier and reduce the cost. That's the overriding hope that sits underneath all of this. And the problem is that this hope is false. I explain a little bit why. So when we're talking about optimizing individual health, you were talking about really focusing on the individual as being the target of the optimization, but the target is actually equitable population health. So we're trying to say that we can police individual bodies and individual behaviors to such an extent that each individual person becomes sort of optimally healthy, never sick, never going to be at the risk of becoming sick because we're going to predict everything, and that this is going to add up to equitable population health. This is actually a fundamental misalignment. It's a misalignment in terms of AI alignment theory. We're optimizing and we're predicting on the wrong thing. It's also a misalignment in terms of epidemiology and social epidemiology theory. And this is because I told you I was going to go down old school for the morning or the afternoon for you guys. This is because the AI-enabled people medicine is designed to identify and act on individual risk. Its objective function, so the thing it's actually modeling and trying to improve, is the causes of cases. This can basically explain why I will get sick, but not my neighbor. But it cannot explain, without the causes of incidence, why people in one neighborhood might have 15 years less healthy life than another. And very importantly, from my perspective, is that it can actually make things worse. It can intensify the problem. It can push the system beyond the point of optimality and into what we would call counterproductivity. And essentially, that's because you're really doing overdiagnosis at scale. We have spent decades building a very confined program of what we do, for example, with the national screening systems. When does it make sense to screen? When does it not make sense to screen? What does that mean? How do we deal with the people who have been screened? Once you move into this space of this idea of where we're going to do predictive modeling of every single person all of the time, you are blending different things that might be, things that are clinical, but it's also increasingly things that are wellness related. And essentially, everyone can always be a little bit more healthy. You can always be a little bit better. You can always perform just a little bit better. Okay, maybe don't take 10,000 steps, take 10,500 steps. Maybe don't just eat 5 fruits and vegetables. You should eat 10 fruits and vegetables. And now we have this scenario where people are expected to monitor how well they sleep, not just how many hours, but how many hours they are spending in deep sleep. How do they have good sleep hygiene? All of this stuff starts to really concentrate on what does it mean to be healthy. And we're constantly expanding that definition to ensure that people are sort of optimally healthy. And the reality is that actually drives up demand, because it starts taking away from this idea that some things are not clinical, they're not pathological, they're just part of life. Some days you're going to be sad, and that's okay. That being sad for a day doesn't necessarily mean that you need to have access to clinical care. It might mean that you need access to your friends and family who are going to make you feel better. But if we drive everything towards this system and this clinical point and this idea that it's clinical prediction, we start to push the system point past the point of optimality. And that is essentially just a term from health economics that means the benefits no longer outweigh the harms. The harms start outweighing the harms, and then counterproductivity means that you start to produce the harms that you were trying to prevent in the first place. So why is this? Why is that a problem? Why is that occurring? What does that even mean? Well, the main one is that there is a considerable difference between prediction and causation. And I'm sure everybody has heard the phrase correlation is not causation. This is essentially what it means. Is association is not causation. Very often in AI predictive modeling, when we're doing individual level modeling, we are predicting on associative factors. So, we might be saying, let's take something, for example, type 2 diabetes. We know that there are factors associated with an increased likelihood of someone becoming diagnosed with type 2 diabetes. That might be a high BMI, but it might be a number of other things. Those are not necessarily the actual causes of the fact that that person is about to be at risk of type 2 diabetes. But that means when we predict on those factors that are associative, not causative, that means that we can't actually intervene on them correctly. They're not modifiable risk factors. Most of the time, especially when we are dealing with like chronic disease, we are dealing with things where the causes are upstream. They are those causes of incidence, as I said, which is Jeffrey Rose's epidemiological theory, or Michael Marmot, the social determinants of health. They sit further upstream. It's the causes of causes. We don't predict on those when we're predicting at the individual level. So if I just was to give you a really, really simple example of what I mean, and take that type 2 diabetes one, for example, you might predict, okay, this person has a high BMI, therefore they're at risk of becoming type 2 diabetic. What we should do is tell them that what they need to do is eat healthier and lose weight. That we don't know, for example, that person lives in a food desert in a non-walkable area, and that they have low mobility for a variety of other reasons, and their income is low. Those are actually the causes of the fact that they have a high BMI that is associated with type 2 diabetes. But what we are doing is, as I said, shifting the responsibility away from the system that is actually causing those issues onto the individual. Which raises the question, are we really empowering the patient, which is what a lot of this logic runs on, or are we enabling the politics of avoidance? And the politics of avoidance basically just says that it's easier and more politically tenable, especially in the scenarios where we have had decades of austerity policy, to say, oh, we're going to make everything optimizable through an algorithm rather than tackle the things that are non-sexy but actually difficult to get right and high achieving, which is doing things like tackling clean air policy, making sure that we have walkable communities, ensuring people have healthier access to food, that they have safe housing, and that we have equity and inclusion in terms of who gets access to care. Now, when we say that this is a problem because we don't have enough data and we don't have accurate prediction models, and that all we need to do is make sure that we have less biased data sets and that we can predict accurately for everybody, we are enabling politicians and people to say that we don't need to worry about dealing with the system and that all these causes of causes, because all we need to do is make sure that we are telling the individuals when they are becoming sick and what they need to do. This is very problematic. It starts turning everybody into an increasingly permanently pre-sick individual, where they are responsible for absorbing all of that risk and all of that responsibility. And you can see in my little diagram, take this pill, check your numbers, do more, try harder. That is a lot of the logic. And we're not shifting that try harder logic upstream to where policy sits to say, actually, we should maybe be thinking about how do we enable healthier environments. So if we know this, if we've known this for decades, if we know that this doesn't really work in terms of logic, we also know empirically, my friends and I, we did a systematic review a little while ago of these predictive models and what actually happens once they're deployed in the NHS. And we found that maybe a third of the time they make some minor difference, a third of the time they make no difference, and a third of the time they actually make outcomes worse. And it's because of this idea, really, of sort of what we might call epistemic capture. When the AI first appeared on the scene in terms of policy making recognition, which is around about 2015, 2016, 2017, once DeepMind started to become to the fore and policymakers at the sort of national level started to gain wind of this and think, oh, this is something that we should be tractable. We really know how to cope with AI policy. So they turned to the people who are the technical developers of it, who primarily, especially at that point in time, were those who came from outside of healthcare. They're very, very good technically. They're not necessarily very good at understanding the actual healthcare system. But policymakers say, okay, let me turn to the experts who do this, the technical experts who understand this. The technical experts come in. They start initially by answering very technical and precise questions. And over time, that power grows. And instead of it just being, I can answer a question about how this algorithm actually works and what can do validation, I can actually start telling you questions like, what is it best used for? What should we use AI for in healthcare? And then that gives you the answers that are already there, solved answers, which is things like computer vision and prediction, because we do computer vision very well in many other domains, and we do personalized optimization prediction also very well in other domains. Every time you log into Netflix, every time you use Amazon, it's the same type of logic is running underneath. And so they start to expand this technical group who come from a good place. This is not a sort of maleficent thing that has happened. It just happens organically. Who come from a very good place. They don't understand the complexities of health and healthcare. They just understand that health clinical care has a lot of data. A lot of data means I can do very highly accurate prediction. And then you start to get this logic where we see all the time papers are published, people give themselves a massive pat on the back because the paper, their model is extremely predictive. Then is a massive logic jump to say, because my model is very predictive, that means that these outcomes are going to shift, and this is going to be very good for the healthcare system. And then that logic gets absorbed into policy, that lets them grow power. And then the people who might actually have a better understanding of what we should be doing from a healthcare perspective are sort of pushed out of this decision-making process. And the entire policy-making machine of what should we be doing with AI, how do we govern it, becomes sort of captured by this technical community. And so it seems. So what do we do about this instead? What should we do in terms of thinking about this and throwing some of these problems out the window and reformulating it? I think we have to change the objective function. We need to change what we're actually trying to model for and what we're trying to achieve. And we can see how to do this by relying on older theory. So if we go to things like social epidemiology will tell us we shouldn't necessarily be focusing so much on the individual, we should be focusing on groups. The groups is the target of which we optimize. Capability theory then tells us that it's actually not by a statistical definition of health that we really care about. It's not so much about wondering whether or not people are never going to have a disease or never have any injury. Sort of trying to push for that as the goal is a bit reductive. It's not how people experience health, and it's also exclusionary because it means that anybody who is living with a chronic condition, anybody who is disabled, for example, is immediately discounted from this definition of health, and we stop trying to optimize for them. Whereas capability theory really tells us that what people actually care about is the ability to live a life that's well led. And that's what health means to them. It's not necessarily, do I have a condition or not have a condition? It's whether, even if I get this condition, can I still live a life? Can I still work? Can I still enjoy my family? Can I still go out to play? Can I still see my kids in their school production? That's actually what people care about. Theories of justice can tell us that we shouldn't necessarily just be focusing on trying to make sure everybody is the same. What we actually want to do is look at how far people are below the ability to achieve their goal of being able to live a healthy life, and prioritize them. And it also means we need to look for a sufficiency. Instead of trying to always optimize right to the top, where I said, everybody becomes a little bit pre-sick because you can always be healthier. What is our actual minimum definition? Where is a sufficient threshold of health that allows people to live a life that they're well led? So that's what we get from justice theory, is that we need to prioritize those who are performing worse, and we need an idea of sufficientarianism. And then systems thinking tells us that what we need to do is actually think about where in the system do we pull a lever that is going to allow us to get the most effective change for the money that we spend. Basically, where do we get the most bang for our buck? And so if you combine all of these different theories, they give you an objective function, which is maximize the population's capability to flourish. So basically maximize the population's capability to live a life that they believe is valuable, rather than try and optimize individual health. And then we can do this by thinking about this in terms of it being like a causal model. I have this slide and one more slide, and then I stop talking, so don't worry too much. I will nearly stop boring you to tears. So you can conceptualize this as a model. So you start with the structural conditions. You start with the causes of causes. You then say that is what causes group disease burden. This is basically what causes the causes of incidence. The causes of incidence then determine the ability of the group to have capabilities, which is basically what they feel that they are able to do. So a capability might be something I feel as though I am able to be independent. This determines group level functioning, which is the things that they actually do. And then we also convert capabilities into functionings. So just because I can do something, I feel like I can do something, doesn't necessarily mean I can do it if there are things that are designed with the system that are wrong. So coming back to that type 2 diabetes example I gave you, I might feel as though I am able to do cooking and healthier eating, and I am able to go out and exercise, but the environment within which I live is preventing me from doing that. That would be something that is preventing that conversion from capability to functioning. And when we get both capabilities and functioning above a sufficient threshold, we get group level flourishing, we get this achievement. Now, what's important is that none of this is static. We are in complete control of our ability to moderate how this works. And we can intervene at different points in the system. So we can intervene that makes sure that the causes of causes, so that we lower the level of group disease burden. We can then also moderate the extent to which, if somebody becomes sick, so we have a high level of disease burden, we can lower the extent to which that restricts their freedoms and their ability to do things. And we can also intervene on the extent to which group disease burden stops people from being able to do something, so that, if there's somebody who's asthmatic, they might feel as though they are able to go outside, but the air quality is too low. If we intervene on air quality, we don't necessarily change the level of incidence of asthma, but we do change the ability of the extent to which having asthma restricts a person's freedom of life. And then we can also intervene on this capability and functioning different things. So the way we can do this with AI is by doing simulation optimization. So you can estimate from a causal perspective those different vectors. So what is causing disease, what is causing things to restrict people's capabilities and functionings, excuse me. And then we can also estimate what happens when we use a policy vector to intervene. What happens when we, say, for example, put in place an air policy, a clean air policy. What is the result of that? We can then simulate what happens over time to different groups of the population when we pull those levers. So if we introduce a clean air policy, what does that actually mean for people's abilities, for people's actual doings, for the disease burden? How does that change for different groups over time? And then we can do what's called optimization, constrained optimization. So which of those different policy packages is going to allow us to achieve the goal of getting a highest proportion of the population above that threshold, which we've set, and stay within the budget constraints. And that's, again, something that we can do with AI with optimization. So you create this loop, the simulation optimization loop, that allows you to shift the optimization target from the individual to the group, and you use it to understand who is, instead of who is going to become sick, you use it to understand what is going to enable us to get the biggest degree of change out of everything. So if we were to summarize this, it's you stop asking AI who is going to become sick. Start asking which structural conditions, if we change them, would shift the curve, which is going to shift the burden of disease. And we need to build the required infrastructure, and this will help us bring population health into the 21st century. So this is what I mean by code for we and not for me. Thank you very much. I stop talking now.
Thanks so much, Jess. That was a really thought-provoking talk, really nicely delivered too. I'm keeping my eye on the Q&A or tab, but I'll just kick things off by asking these kind of population level AI tools or use cases. What kind of interventions do you see them pointing their users towards? Is it to help shape policy or interventions of other forms, presumably not kind of drugs and treatment choices as we typically think about?
And so you can do it at two different levels. We'll call it in modeling macro level and meso level. So in the macro level, that would be some of the things, policy interventions that I was talking about. So there is a very famous model that does this, for example, for cardiovascular disease, and they model the various different outcomes if you were to do things like change the salt policy, or to change things like introduce the sugar tax or stuff like that. So that's a sort of macro level thing that you might want to look at as a policy, because it is intervening in that first point. It's lowering the causes of incidence, it's lowering the disease burden, full stop. And then your meso level policy vectors are things that essentially mitigate the impact if disease has happened. So that could be things like employment policy, fair employment policy. It could be things like fair housing policy. It could be things to do with the benefits, or it might be, if what we are dealing with is something that's more clinical, looking at where we put access to care. So do we need to put a clinic in this location instead of that location? And what happens if we do it under different scenarios? So yeah.
Yeah, that's really interesting. And interesting, I suppose one of the issues we bump into as well quite often is medical device regulation around AI software and at this kind of strategic level. Um, I mean, I don't know how it would fall, but I can well imagine that there are many use cases that wouldn't fall inside that remit,
Yeah, exactly.
which would be, as you say, much more sort of agile system potentially.
Yeah, because it's shifting the response, the role of the AI from being the thing that makes the decision to being a thing that helps enable human decision making in a more transparent and evidence-based way, and sits less outside the remit of things like medical devices.
Mm. And on that kind of note of agility, I was really struck as
Mm.
well by your point that AI's challenged that separation between research and clinical practice,
Mm.
which I think is something um, we've seen brought by lots of different members of the community. And in practice seems to basically depend on individual risk owners and gatekeepers in their place making decisions about where those lines lie. From your perspective, are there any particular characteristics that you think are useful in AI for defining what's research and what's not? And the generalizability of the findings coming out of the activity is often pointed to, but I find that that's tested in some spaces as well. Do you think there is a dichotomy there still, or?
So no, I think the dichotomy is gone, which I think is what is the problem. And if we were to be really, really strict, I think it's not just the split between research and practice that's also gone. It's also research, practice, and service analytics. So how well is the system actually performing? Those are our three typical use cases that we split data into, and AI sort of collapses them. And I think if we continue to try to force AI into a category, that's where more of the risk comes from. Whereas I think if we were to accept, hey, this is the world we're now in, these separations are not really there, we might get to more productive way of coping with the risk.
Thank you. I've got some questions coming in on the chat, so I'm just going to try my hand at unmuting folks. So first up, I've got a question from Eugen Cho, who hopefully I've unmuted you, Eugen. Just see if you can speak. If you could speak to your question, that'd be great.
Yes, can you hear me?
Yes, loud and clear. Thank you very much.
Yeah, thank you so much for the interesting presentation. It's just a small question about the definition of a population or a group that you have in mind.
So if you were doing this officially, you would need to define them a priori. So you'd have to try and define them, define the groups before you started modeling. But it can be anything from a group being a specific locality, but that would be a bit difficult. Or you might want to break it down by groups that are by specific demographics or specific ethnicities or specific people who already have vulnerabilities for certain causes of disease, but it's going to depend on the question that you're answering, and it has to be defined a priori.
Oh, okay. Yeah, sure, I see. Thank you very much.
Thanks very much. Next up, we've got a question from Kevin Flanagan. So hopefully, Kevin, I've unmuted you there.
Hi, thanks, Jessica. I love listening to your thinking on this pretty difficult subject. But I've got a question. If there's two very big areas that kind of get glossed over, mental health and aging populations. And do you think AI might be any use there? And particularly taking this idea of looking at groups that you're talking about in this presentation. I do agree with you that I think current implementations look like they're going to increase demand on an already stressed system, and that'll probably break it rather than actually improve things. Thank you.
Yeah. Oh, that's a great question. So let's answer it in both ways. So first of all, in terms of the type of stuff that I am talking about, I actually think aging populations and mental health are two of the biggest use cases for doing the type of modeling that I am describing. because, for example, we know there is prior evidence to show that clinical depression has a bigger impact on people's capabilities and functionings than something like chronic heart disease. And we do not at the moment do very good systems design to try and help people who are living with chronic depression to make sure that they are still able to live a life well led. And in fact, we have taken away enormous amount of the resources and things that would make it possible for people who are living with chronic mental health conditions still able to exist well in the community. We've lost a lot of sort of community care settings that give people a feeling of where they are belonging. We have lost a lot of things that do support services, and that's also similar for an aging population. So if we were thinking about the problem with aging population, and that one of the main issues there being loneliness is not solved by predicting this person is at risk of becoming lonely. Lonely is in the aging population is making sure that people who still feel as though they have the ability to be independent can actually still participate in the community. So if I was thinking about my gran, she's 94, she still loves to play bridge, but what she can't do is get from the location of her house to where the bridge club currently happens. And the area within which she lives lost their patient transport contract. So they do not have, for example, an ambulance that is on lease to the community that will pick up people and take them to somewhere like Bridge. That's a population level intervention that we can model the impact of, that's more effective than doing something like prediction of individual health. Now, if I was to be more generous and start thinking about where there is benefits of doing it in the predictive way that can intervene for mental health and the aging population, there are good use cases. So falls would be a really good one. We are pretty good at understanding who is most likely to be at risk of falls. And then we're pretty good at being able to then go and say, okay, these are the people who are most likely at risk of fall. This is a very clear, avoidable emergency admission. If we make sure that that person has access to the care and the support that they require, that's going to minimize the risk of falling, which is a good one for an aging population. And from a mental health perspective, the prediction one is not so good, but there is definitely growing evidence that some of the stuff that's related to the sort of generative AI and LLMs can potentially, for people who have the right initial status, be quite useful for giving people access to care when they're not necessarily inside a clinic. And I think that's something that's potentially very powerful. I'm being extremely cautious because there are risks that come with that. And we know, for example, that some people who have lower level of health literacy are going to be more vulnerable to manipulation by an LLM, and that's going to be worse rather than more helpful. But there is developing potential benefits there.
Thank you. Actually, I was just going to ask a quick follow-up.
Yeah.
I mean, I was thinking of those from we've been using a biomedical model in mental health, but
Yep.
really we should be using a biopsychosocial model, which is why I love your thinking, because it sort of keys into that. And that's more that sort of meta level I was wondering.
Yeah. So yes. So from that perspective, yes, I think if we are doing modeling, and that's really what I'm getting at. In fact, that's where the original thinking of all of this came from, was let's stop optimizing for a biostatistical model and start optimizing for a biopsychosocial model. What worries me sometimes is that then gets interpreted as meaning we just need to put more factors into a predictive model. So we just need to start thinking of, we also need to do things like, shove a postcode in, or we need to shove proms inside a predictive model. That doesn't do anything to change the intervention vector. It's still only operating on the associative rather than the causative thing. So modeling more to understand why are people suffering from mental health more at risk or more vulnerable in this locality, this demographic, this age, and what can we actually do to enable them to still participate and partake in real life, even if they are suffering with a chronic mental health condition. Yeah.
Thanks very much. I'm just dotting around the questions a little bit, bouncing off what you were saying about which use cases may or may not be more useful. for individual predictive model stuff. So I'm going to bring in Sarah Cook, who's got a great question around those lines. Sarah, can you try and speak? I think you're unmuted. If not, I'll dive in. I don't think it's going to be working. So, really interested in your thoughts about how we prioritize which use cases of AI we focus on as a system. There's so much fragmentation and people going their own way. What would good look like for decision making?
A great question. So I think in the world of the NHS, we have to always constantly balance between what is useful decision making that gets made structurally centrally versus where we still want to actually leave some decision making to be devolved. In this particular instance, and in what is the overarching aim and ambition for what we are trying to achieve with AI, I think that is better held as a central level at a very highly abstract perspective, because then it does things like determine where the money goes and what people get paid for adopting. So I have a big concern, for example, right now, that there's such a big push for paying for people to adopt screen readers. So things like, for example, that will algorithms that will do prediction or reading of breast cancer risk. There isn't simultaneously money being released from the center with how do you increase the capacity to treat the people that you might now be picking up and who were not there possibly at the same time. I know, so good decision making for me looks like you follow the entire pipeline down. So it looks like going, okay, let's have an actual look at this signal of what's currently happening in the healthcare system. So where is the real identifiable need? And that would probably involve talking to people on the actual ground and talking to people in different localities. Where is the greatest pressure points? What are the things that are really stressing you? Which is not the same as asking what currently AI is available for us. It's saying, what's the problem? How could we solve this with AI? Could we solve it with AI? Is AI the right solution? And then following the entire pipeline down. So, okay, if I think that this problem is solvable through the use of AI, what are all of the requirements that I need to put in place in order to make sure that that's a sensible solution? And those requirements might be very technical, so they can be extremely basic things, which is where I think the locality comes back in, which is literally just, do you have the variables that this model is using on site? Are you actually recording them in your electronic health record or not? And then that might be a case of saying, okay, if you're not, we now need to give you the money to put in place an electronic health record that does record these variables. Or it might equally be things like, okay, we need to put in place a training program for the staff that you're now going to use. And we might need to also think about how we adapt our consent model for the patients so that they understand that this is happening in the background of their care. So that, for me, that sort of circular and then linear planning is what good looks like for AI and decision making. Yeah.
Thanks very much. Planning for success. That sounds very sensible. It's funny that all of the things seem to assume they won't have too much impact, not too many problems to deal with.
Turns out they do, but we often ignore them when it comes to AI. Yeah.
Yeah. Actually, I've got another question that's not attributed to anybody in particular, so I'll just read it out. This is a really interesting approach. I imagine many of the target factors identified by AI would overlap with existing evidence about social determinants of health. How do you envisage this would evidence or encourage policy change more than current evidence does?
So yes, they would overlap with some of the social determinants of health. That's why in the slide I say causal estimation rather than causal discovery. In terms of where I think it can influence how policy more, there's a sort of scientific answer, and then there is the more me going to get cancelled answer. But the scientific answer is that when we actually have better understanding of what is going to happen when we pull and intervene on those levers, and you are able to do that counterfactual modeling. So you are literally able to say, if you do this rather than this is the outcome that you get. I think right now, for many decades, a lot of the social determinants of health stuff has been, we know this is sort of happening, but the complexity of how we intervene has greatly exceeded the sort of human capacity to plan. We knew for a long time, right, if we give people access to healthy water and clean water, and we do seat belts and all of this kind of thing, that's making a very immediate impact. A lot of this stuff now in the social determinants of health and how we intervene as a policy level, the long-term impact of that is sort of unknown. It's instinctively known, but it's not quantifiable. Whereas if we start shifting to this and saying we can actually quantify that and we can start showing you what you're going to get, I think that starts making a big difference. The other sort of more cynical side of it is that this also aligns perfectly with the current government's agenda. It's just that they don't realize it yet. So the logic and the framing is all there of this idea that we want to do prevention rather than sickness, and that we want to shift things upstream. Just the actual operationalization of that is quite poor in strategic thinking currently. So we are sort of not trying to go against the grain. We're trying to say, actually giving you what you need. And then the final bit is just that it's AI. Everybody loves AI. So those that like to pay attention to things when you do things with AI, which is, yeah, the sentence that gets me cancelled, but it's also the truth.
Yeah, no, good point. I've got another one. There's some very complimentary foreground to this, but I'll leap to the question bit. So, but please do dig into that. Thinking about interventions like everyday infrastructures like swimming pools, bus routes, bus stops that help people stay active and access care. How do we make those arguments persuasive to policymakers who are under pressure to deliver visible results much sooner?
Great question. So basically, it's the same answer by showing them what the counterfactual is. So right now, when you give people those arguments, they sort of think it's this or nothing. They'll think, oh, I can't understand at all what the impact of this is going to be in 5 years' time, or 10 years' time, or 15 years' time, and I'm on a political cycle and I need to intervene immediately. But if you are able to show and say, actually, when you compare the impact of this and this over the two timescales, you're getting way less from this, even though the impact is immediate, than you are from this. I think that's actually a quite powerful message that you are able to communicate to the public, to say, look, I'm doing more, right? I'm investing more in the actual outcome and going to give you more than what you're going to get if I do this right now. And that is a thing that voters and people would get behind, and it's where the advantage of there being data that actually shows it comes from, because it allows people to make that argument in a more sensible and more clear and transparent way, which I think is ultimately all politicians are ever trying to do, is to communicate to the voters, and this helps. Yeah.
Thanks very much. And you'll have to forgive my chairing here. I'm going to leap round to a question that kind of kicks off some of your answers last time about kind of infrastructural readiness, if you like, for AI solutions, and maybe excessive emphasis in sometimes to adopt. So the question says, the UK government talks about investing in healthcare AI, but some places are still using fax machines. If you were given power over spending, given your focus on population level work, what would you spend money on in the UK? Fixing the systems to get better data, or on AI algorithms? You can't say both, I'm afraid.
That's really easy, fixing the systems to get better data.
Yeah.
The short answer, but yeah.
No, I think that it crystallizes all those points nicely. And then we've got a final question. I think I'm just going to bring in Brenda Riley to speak to, and then we'll give you a break and say thank you. But Brenda, I've just unmuted you, I think, if you're able to speak to your question.
Yes, I was just wondering, it seems as if to me that what you're saying is that it's the causes and the factors in the causes that are important. Does that define what one model from another? Do you label the models in terms of what causes they're based on, or what causes you assume they're based on, or what factors you consider? Is that what a model is?
That's a great question. The answer is sort of yes and no. So the model is the thing that you interact with. The thing that changes is the underlying algorithm, which is essentially the architecture, and then within that is the variables within which you are predicting. So you can change the variables. So you could change and look at the different factors. So I could theoretically take the same type of, let's just use it for easy, model, and take, instead of looking at each individual person's clinical conditions, so their blood pressure, their height, their weight, their blood sugar level, and swap out those for things, for example, like your postcode, the air quality of where you live, whether or not how many steps a day you take, and what you last bought on your Tesco shopping record, and that be something that sort of gets at the causes. It's a little bit different because the actual algorithm, that architecture that you're using in the interim level, has to do different things. And so then we actually need to use different types of algorithms. So instead of using an algorithm that is designed for predictive optimization, you choose an algorithm that is designed to look at causal inference, which is an entirely separate branch of AI.
Thank you very much. And with that, thank you once again for an excellent presentation and excellent question answering stamina too. There's been really helpful responses. Thanks for taking the time out to take us through all of that and discuss these ideas.
Thank you so much for having me.
No, it's been a real pleasure to host you. And for everybody out there, thanks for dialing in this very, very warm afternoon. Just a quick heads up for next time. On Wednesday, the 29th of July, we've got Rory Truss, director at a UK law firm, Burgess and Salmon, who'll be speaking about liability for patient harm caused by AI's medical device. So do join us then too, if you're able. And thanks again to everybody for joining us, and enjoy the rest of your evening or indeed mid-morning or afternoon. Bye.
Thank you.